In question D is a little bit more difficult than A in that we have a binomial denominator and a binomial numerator, and we have roots in both parts of the denominator. But we can still use our conjugate pair in this case because the conjugate pair will give us a square minus a square, which will get rid of the root 3 and the root 13 in the denominator. So I start with 3 plus root 3 divided by 3 plus root 13 divided by 3 minus root 13. And I'm going to use a conjugate pair of 3 plus root 13 in the denominator. So the conjugate pair has to be based on what's in the denominator. So I'm going to multiply by that, and then I'm going to end up multiplying the numerator by that same factor. Otherwise, we change the value of that fraction. And when I multiply this, I have to remember I'm multiplying a binomial with a binomial, so I have to be careful of my product. Okay, so I'm going to do the numerator first. The first is going to be root 3 times root 3. That's going to give me 3. That's first, outside, so plus root 3 times root 13. They're both square roots, so I can multiply the radical parts. So I get root 39 inside. So it's going to give me root 13 times root 3, which is root 39 again, and then my last. So I end up with root 13 times root 13. I end up with 13. Now I did not rationalize the numerator because I have square roots left over, but that's okay because I don't need to rationalize the numerator. When I rationalize the denominator, I get root 3 times 3, root 3. Then I get plus root 3 times root 13. That gives me root 39. And then the next term is going to be negative root 13 times root 3, which is going to be negative root 39. That's the key. When we have our conjugate, we're going to have a plus and minus, and that's going to cancel out. And then negative root 3 times positive root 13 is going to be negative, and I'm going to end up with a minus 13 there. Again, the key was to generate that there. The conjugate will give me the zero pair there, and that allows me to then rationalize the denominator. So simplifying this, combining like terms, I get 16 plus 2 root 39. There are no common square factors in root 39. In the denominator, I get this cancels out. So 3 minus 13 is going to give me negative 10. I do have to simplify this. So there's a common factor of 2. So this simplifies to 8 plus root 39 over negative 5. Now that negative is awkward there. So although this is correct, we could either express this as negative 8 plus root 39 over positive 5 to keep it a positive denominator, or equivalently, we can just distribute that negative and say that's negative 8 minus root 39 over 5. So all of these are the same solution.